Hello, I'll be discussing option one, basically talking about the grasshoppers that were given the deadly fungus and how ectoderms deal with fever. So it's very similar, but also very different than how endotherms and ectotherms deal with it. Um, I'll also be touching on structure function and how that also is a core concept of fever, especially when it comes to ectoderms in this case. When it comes to ectoderms and endotherms, the temperature basically is increased. So when a person develops a fever, their body heats up, it becomes increased, and that can help with survival. However, it cannot pass a certain temperature, like it cannot be hotter than that specific temperature because if it starts to get hotter, um, the function of proteins that really help this process to happen won't happen because of structure function because the protein is denaturing. So when it comes to ectotherms like grasshoppers, they basically they behaviorally change their temperature. So when they're out in the environment, they look for, places or things that can help them change their temperature to align with how they need to feel. So they either bask on a rock if they want to be warmer so the sun can reach them, insects in that sense, or they hide under a rock, let's say, for instance, to get colder if they're too warm. So it's very different in that sense. This also shows kind of how evolution plays into this, where it shows the different ways in which ectotherms and endotherms deal with it differently. They both do need a hotter temperature to help them like fight off pathogens, but it's regulated in a different way. So basically what happened in this study that were shown is that these grasshoppers were given a deadly fungus, a fungal pathogen basically, and they were placed into either colder rooms or hotter rooms. And based off of where they were put into, it was seen that the ones that were in the colder rooms, they were less likely to survive. It was a less proper probability of them surviving, and the ones put in a hotter room, they were able to survive more at least. It's basically showing how when a fever is produced because of a virus, in a sense, and to fight off that infection, it's necessary for the body to be warmer, so the molecules can move faster, and so that the molecules can be able to fight off this pathogen, like in terms of the enzymes being able to be activated and catalyzed, so they can go on with these reactions and fight off the pathogens. However, it was way more than the optimal temperature. If it becomes way hotter, in a sense, the body gets way hotter than like the optimal temperature, then basically a pathogen's proteins will no longer be able to work, and so they will denature and um like the enzymes can stop working, and that's when it can be bad and no longer can survival occur.